Hi everyone, Marcus again, and I have my good pal James Sloane, the medical scientific genius expert guy, who is going to give his little 2 bits on today's subject, which is cancer. The big C. But before we start, I have to say this. Nothing is going to cure you of anything if you don't stop doing what causes the problem in the first place. You can't keep eating the same foods, hanging around the negative people, doing things that you hate, that are sucking your energy dry and killing you. You have to change the things in your life that made you miserable, that are killing you. It's not just what goes in your mouth. It's the whole package deal. You have to look at that. You have to stop doing things. You have to let go of certain things that you're hanging on to, which are killing you. And you have to clean out your life, clean out your body. And once you're doing that, and then you start putting good stuff back in, what we're about to tell you is the final fine-tuning, the powerful things that can just knock out whatever you have left. So don't think you're going to get rid of cancer just by taking some magic herb or doing some kind of fancy therapy. Okay, you have to take responsibility of your life and your choices. So having said that, you are about to hear some really powerful ways to just knock out that last little bit. Here we go.
Yeah, I took up researching cancer back, I was actually in high school because I was working on some projects with, I was really big into sharks, and you know, you always hear sharks don't get cancer type thing and all that. I was researching sharks and trying to figure out how to utilize the sharks in cancer therapy, so I started doing the research back. Well, that was what, 9th grade I started into cancer research, and in order to understand where I was going with my research project, I had to learn everything I could about cancer. So I've been researching cancer ever since. While I'm mentioning sharks real quick, the whole thing about sharks getting cancer is a myth. Sharks do get cancer, and it has nothing to do with their cartilage whatsoever, which I'll get back into that a little bit, but they have found sharks that have cancer, and like I said, the reason that sharks rarely get cancer is because of their immune system, which is way different than ours. It has nothing to do with the cartilage whatsoever. They just basically produce antibody interferon levels 10 times higher than humans do, which gives them a higher immunity than we do. Anyways, getting back to cancer in general, I'm actually working on a book right now on cancer because I've ran into so many myths. I mean, there's probably more myths about cancer than any other disease out there. And the stuff, basically what happens is that somebody comes up with some weird idea and they state it, and then somebody takes that idea and they twist it a little bit, put their own spin on it, and then it gets twisted, and you know, and it keeps going on. Great example of this is one of the most common myths we hear about cancer is that Otto Warburg won the Nobel Prize for showing that cancer cannot survive in a high oxygen atmosphere. None of that is true.
I remember that, yeah.
Yeah, absolutely none of that is true. Well, Warburg won the Nobel Prize. In fact, he only won one. Some people claim he won 2. No, he didn't. He was nominated for a second one, but was not awarded. And he won 1 Nobel Prize, and it was for the discovery of an enzyme that he called iron oxidase. That's what he won it for. It had nothing to do with
the oxygen in the environment.
Yeah. Oxygen, you know, it affects cancer. Anyways, and since then, his whole hypothesis on cancer has actually been disproven since then anyways. But still, people take this and it seems to just grow and grow with people sitting there saying, you know, now I heard one doctor sit there and say that Warburg won the Nobel Prize for showing that no disease can live in a high oxygen atmosphere. And so the story just keeps expanding and it keeps expanding. Now, what the reality is with cancer is cancer, even though it's often called anaerobic, it's not really anaerobic. It actually relies on both anaerobic glycolysis and oxidative phosphorylation, just like our normal healthy cells do, and they're highly dependent on oxygen for survival. So that whole thing about high oxygen atmosphere killing cancer cells, no, it does not work. If it were that easy, we could use hyperbaric oxygen therapy to cure cancer. It doesn't work. We could go scuba diving and it would cure our cancer. It doesn't work because oxygen does not kill cancer cells. Now, ozone will, but ozone is got different properties than O2, which I can get into that a little bit later. Cancer, basically, to understand the whole oxygen thing, is that when the cancer cells first start growing, they can only reach about 2 to 3 millimeter in size. And as long as they're down, you know, this little 2 to 3 millimeter in size, oxygen can diffuse through the walls and the cancer cells can survive. Once they get beyond that 3 millimeter size maximum, the interior of the cancer cell actually becomes oxygen starved and it dies, and that stimulates a process where you get angiogenesis growth factors, like vascular endothelial growth factor, for example. What this will do is these compounds will stimulate the growth of blood vessels from a primary blood vessel and from the tumor at the same time. These blood vessels will grow out until they contact each other. Now the tumor can get plenty of oxygen, can get plenty of food directly off of blood vessels. So in essence, it's like parasitic in nature.
Right, yeah.
And at that point, the tumor also will produce what they call angiogenesis inhibitors, which sounds kind of strange at first because here it's forming these angiogenesis growth factors to form blood vessels, but it's also forming blood vessel inhibitors. The reason for that is they do it in very, very small amounts, and those angiogenesis inhibitors go back out into the bloodstream and they circulate around to suppress the growth of secondary or metastasized cells. And so this way it's survival of the fittest. That primary tumor is going to sit there and get all the food, all the nutrition, which is one of the reasons when you take out that primary tumor, you take away the source of those angiogenesis inhibitors and allow
the secondary ones now don't have competition anymore.
And so they grow back within 2 to 3 years. That's one of the reasons for cancer to come back in a short period of time.
So what would you say is the best thing? Is people that are out there freaking out right now about having cancer, what would you say in terms that they can understand would be the best approach for them?
First thing, maintain your immune system. You know, things like try to avoid stress as much as possible. That's a big factor for your immune system. Stress, stimulants, and steroids will crash your immune system so fast. And so talking about stimulants, you know, give up the Red Bull. All these people are downing their coffee and their Red Bull and they're smoking their cigarettes, and all these stimulants are going to sit there and weaken the adrenal glands and weaken the thymus, and it's going to create severe immune suppression. You also want to maintain your intestinal flora. The intestinal flora are about 70% of your immune system, so you want more fibers in your diet. More vegetables, more fruits. You can, add brands or whatever if you want, if you're not getting enough fiber in your diet. So basically you want to start increasing up your flora.
The reason you're saying fiber is because that's what feeds
the flora.
There's a lot of people that drink or take probiotic pills, which is probably dead. They've been on the shelf for like 20 years,
Or shipped in the heat.
Right, and then it hits your stomach acid, which kills most of it anyway, so most of them aren't going to make it through. So the idea is to feed the ones that you already have in there.
Exactly.
And what they love to eat is fiber, right?
Yeah.
And that's basically what most raw fruits and vegetables are made out of.
Exactly. There's prebiotics and there's probiotics. Now, probiotics are what people are more familiar with. Those are your capsules or your probiotic cultures like kefir and sauerkraut and so on and so forth. The drawback to a probiotic is that you have a limited number of strains. There's actually several thousand beneficial strains of bacteria that inhabit the body. When you sit there and take a probiotic pill, you might get anywhere between 1 to 17, 18 strains at the most, and that's all you're going to get. You're not replacing those other thousands of strains that your body's supposed to have. So it's better off going with a prebiotic in the long run, because the prebiotics will feed all the flora. Because even if you take antibiotics, you're not going to kill off every last bacteria. There's always survivors. Just like if you spray cockroaches, there's going to be survivors. They build intolerant. So you want to sit there and feed those survivors and build up all of the strains and not just replace a couple.
So what is a prebiotic?
Prebiotics are fibers.
It's food source for the probiotics, right? Probiotics are the little creepy crawly germy things inside you that are good for you.
Exactly.
And the prebiotics are their food source.
Yeah, fibers like, again, I like oat bran. Rice bran is really good. They're very high in B vitamins, so they're good nutritionals.
What about apples? Is they're high in fiber, pectin?
Yeah, the pectins are a source of fiber. Seaweeds are a source of fiber.
I noticed that a lot of the probiotics, when you buy them in bottles and things or the liquids, they love to live off of sugar or any kind of sweet thing. So, but the irony is, so do the bad guys. They like to live off of sugar too. But I guess an apple, it's got fiber, it's got natural sugars, it's got
beneficial acids like chlorogenic acid, which is anti-tumor.
Yeah, and it's got the malic acid, which is good for cleaning out your kidneys and
builds ATP levels, which again helps with cancer.
Yeah, so just eating stuff out of nature is just so simple. It's already figured it all out for you.
Yeah, green apples are better than the red ones too.
Exactly.
If you're going to go for malic acid.
High in malic acid, yeah.
Before I forget, on cultured foods, one of the things I should bring up is a lot of people go down, they'll buy their little yogurts. It says live culture yogurt on it. No, majority of those yogurts are not live culture, and it's really simple to prove too. If the cultures are live, the cultures are still active. They're fermenting the sugars. When you ferment sugars, you form gas. So like if you take a bottle of kefir and you have the kefir in the refrigerator, the container starts to swell. It's not going bad, it's just generating gas from the fermentation process. Now these yogurts, they're not fermenting. You don't see the lids blowing off or anything like that because those cultures are dead. They were live at one point, but they sterilized the containers before because they don't want people thinking that, oh, it's it's going bad because they think of salmonella or whatever. So anyway, they're gonna, or actually botulism is what spangs the can, so they're gonna sit there and think in terms of that. So they don't want those containers expanding or blowing open on the shelves and stuff. They kill the cultures before they send them to the store. They're not live culture.
Okay, so we have probiotics, we have no stress.
Stay away from the stimulants.
Stimulant, no stimulants.
Yeah, there's a lot of medications that weaken your immune system too, particularly steroidal medications. So if you can avoid, like, if people on steroidal inhalers and stuff like that, there are ways getting around using steroidal inhalers. And if you can get off those, that will do wonders for your immune system.
So people with asthma who are like inhaling that stuff, they're actually upping their chances of getting cancer.
Yeah, they're weakening their immune system big time. They're crashing their adrenals and their thymus, or even getting steroid injections. You get an ache in your knee or something, all a steroid injection, and that all weakens the immune system. So that's a big factor. And then antiviral compounds are really, really helpful. If you do the research, you'll find that the majority of cancers have a viral origin. In fact, almost all cancers, I'd say about 95% of cancers have been shown to be viral in origin. And as far as these hereditary cancers, no, I've only seen one potential cancer that could possibly be hereditary, and that's familial retinoblastoma, which is a condition in which babies or newborns will form tumors within the eye. And because of the fact that it's as a newborn, okay, there is a potential genetic factor that, or I should say hereditary factor, not really genetic, because it's all genetic if you stop to think about it, because okay, we're talking about the genes in the cells, but in this case hereditary. All the stuff about hereditary breast cancer, hereditary prostate cancer is all bogus. They have never found a human oncogene. All the oncogenes have been found to date have been viral in origin to begin with. And then, like Angelina Jolie, of course, recently got the breast removed and all that because they were saying on the media she has the BRCA1 gene. How many people realize the BRCA1 gene happens to be a tumor suppressor gene?
Really?
Yeah, it's not a tumor-causing gene, it is a tumor-suppressing gene. It's a mutation in that tumor suppressor gene that blocks its ability to suppress tumors that can contribute to cancer. But those mutations come from viral infections. Now, if you stop to think about it, if it was hereditary, a person born with a hereditary condition has that condition from birth. It doesn't show up 30, 40, 50 years down the line. You are born with it and you have the symptoms from day one. So all the stuff about the breast cancer being hereditary, prostate cancer being hereditary is totally bogus. Those are viral induced cancers. For example, we know that the various human papillomaviruses can cause breast cancer, skin cancer, prostate cancer, nasopharyngeal cancer, anal genital cancer, and so there's a long list of different cancers HPV viruses cause. And there's leukemias and lymphomas, for example, are caused from various viruses. Epstein-Barr virus through the human T-cell leukemia, lymphoma viruses 1 through 4, and so on and so forth. So if you really do the research, you'll find that almost all the cancers have been linked to viruses. There's a few that are bacterial, very few, like H. pylori, for example, has been linked to a few cancers, like stomach cancer. There's a couple of rare fungal cancers, usually from mycotoxins like aflatoxin from Aspergillus niger, for example, can cause liver cancer. Parasitical cancers, super, super, super rare. So the whole thing, Hulda Clark is a big pet peeve of mine. So, but parasitical cancers are extremely rare.
So wrapping up the cancer thing, any last words of advice for people?
Oh yeah, avoid aspartame. Get aspartame casein will break down to formaldehyde, which is a very potent carcinogen. Aspartame is your equal NutraSweet, stuff like that. So you definitely want to avoid things like that. Exercise is good. Keep your circulation going. Stress is one of the biggest things. Keep your stress down. Yeah, that's a big factor. Good nutrition. And when you get into, say if somebody does have cancer, there are things that can be done that will effectively treat cancer, but there's also a lot of stuff out on the market, or a lot of stuff being hyped up. Again, alkaline waters being one that does not touch cancer. Drinking baking soda will not cure cancer. One of the big pet peeves out there is cesium chloride, which is highly toxic, and it's being pushed as a cancer cure because they're sitting there saying it alkalizes the cancer cells again. But again, cancer cells are more alkaline than a healthy cell, so they're exporting those hydrogen protons to the external matrix to protect themselves from the alkalinity. But the people pushing the cesium chloride are sitting there saying that, oh, the cancer cells can't take up oxygen in an acidic environment, and therefore that's why they turn cancerous, because they're not getting oxygen, and it's all total BS.
Look at these people that do really high doses of vitamin C therapy. They even do intravenous vitamin C. What is vitamin C? It's
ascorbic acid.
It's acid, right?
And the excess vitamin C that's not utilized by the body is broken down to oxalic acid. And so it's not going to do you any good either. In fact, the synthetic vitamin C sold as ascorbic acid is extremely unstable. Back in high school chemistry, we took samples of the vitamin C crystals and took 3 samples, did light, heat, and moisture, and in each case it was completely destroyed in about 40 minutes. When we retested it for vitamin C content, there was nothing left. So one of the things that a lot of people, when they have cancer, they go in for these vitamin C or ascorbic acid intravenous injections. Now here you got the IV bag, it's clear, so it's being exposed to light. It's in water, so it's being exposed to oxidation from the water, and then it takes for an IV to go into your system, you're talking about probably a couple hours, yet it's going to be destroyed within 40 minutes. So what's going into your body is mostly not ascorbic acid, it's mostly oxalic acid from the breakdown of ascorbic acid in the IV.
Right, but real vitamin C from berries, acerola berry, amla berry,
they tend to be more stable.
Right, because you grind up the berries, and it's even pine. The pine trees outside, right?
Oh yeah, pine needles are about 300 times higher in C than orange.
Yeah, and I showed people how to make tea out of pine needles, and they said, yeah, but you're killing the vitamin C by boiling it or heating it.
No, not necessarily. It depends on the plant as to the stability. Like you did mention camu camu, which is one of the few I don't really bother with because it does have an instability issue with it. But your other sources of vitamin C, such as amla and your berries and stuff, they have polyphenols in there that actually protect the vitamin C from oxidation. So in other words, there's an antioxidant protecting the antioxidant from oxidation. So it stabilizes it and makes them somewhat heat stable. So you actually are going to maintain a lot of the vitamin C content.
Because pine needles are kind of hard to, you can't just like, I mean, you have to do something with them. Either put them in a blender, juice them, or make tea or something to soften them up a little bit. So the heating of the pine needles in tea is there's still going to be vitamin C.
Yeah, you will lose a little bit, Grant, but same with the other vitamins that are heat sensitive, but you're not going to lose it completely. And with the high levels on there, that you're still going to end up with a significant amount in there. And also keep in mind that your body doesn't require high levels. When they're talking about the RDA for vitamin C, let's say even if I don't know what it is offhand, I think it's like 60 or whatever, which is low, but a lot of people recommend anywhere from 1,000 to 1,500 a day. They're talking about synthetic vitamin C.
The stuff that isn't really that good for you.
Yeah, your body can't utilize actually more than 800 at a single dose.
But the synthetic vitamin C, anything you said over 1,000, I think it is it's an oxidant, not an antioxidant.
Right, and it's going to break down to oxalic acid.
It's doing the opposite of what you want it to do.
Right. You'll hear some people that can't take vitamin C because they get kidney stones, and the reason for that is that the vitamin C is being broken down to oxalic acid. It binds to calcium from calcium oxalate, which ends up leading to kidney stones. But like I said, there's a difference between natural and synthetic too, because if you have something that's stable here, you can get by with less than something that, if you take 1,000 milligrams ascorbic acid from the health food store, for example, how much of that is actually vitamin C by the time you take it? You might have maybe 200-300 of actual vitamin C activity left in it that hasn't broken down by the time you ingest it. And that's why you're taking larger amounts of synthetic compared to a natural.
Right.
If you get by a natural, like amla berry, for example, we mentioned that one, the vitamin C in amla berry was found to be 12 times more powerful than synthetic vitamin C. So even if it's, let's say, 100 milligrams of vitamin C in the amla, now you got to multiply that times 12 to get what you're actually getting in vitamin C activity.
So if you grind up dry an amla berry and grind it up into a powder, and then it sits on a shelf, and you buy that powder from a store, is it still, did it oxidize away, or is there still a good amount of vitamin C in it?
There's going to be a good amount of vitamin C because, again, there's a high level of polyphenols in the amla berry that protect it. They even shown that the vitamin C in amla berry is actually heat stable for the exact same reason.
Wow. How long does it last? Like if you put it in a bag on a shelf somewhere?
If you keep it out of the light and keep it, a good room temperature, not in heat or anything like that, the amla should be good for at least 3 to 5 years.
Wow.
It's pretty much the same for all herbs. So we're talking about cancer and going into some of the different therapies. There's so many therapies I've seen out there. That's why I started writing this book, because there's so many scam therapies out there. Like oleander is being promoted for cancer, and even though all the studies, including the ones sponsored by the people who manufacture it, have shown it doesn't work. But again, the studies are being misinterpreted and sitting there saying, oh yeah, the people they're still alive at 4 months and stuff. But if you go in, you read the studies and you understand the studies and stuff, what's interesting is the median survival rate on that was 4 months, but the people, in order to enter into the study, your expected lifespan had to be a minimum of 6 months. So that tells you something right there. So there is a lot of scam stuff out there, but there's also stuff that works, and that's what we really need to try to separate the two. Now, my personal favorite, the most effective thing I've seen for cancer so far is ozone therapy. If you don't have access to ozone, you can get by with peroxide in some cases. I'm talking about 35% food grade, not the 3% you buy in the brown bottles. It depends on what kind of cancer you have, where it's at. That's why you're kind of more limited with the peroxide than the ozone. But where I tend to use the peroxide is not through ingestion, because it takes forever to build up to therapeutic levels. Because you're taking the 35%, you're diluting it down to a 3% solution, and you're adding like 1 drop to a glass of water, drinking empty stomach, then you work up to 2 drops and 3 drops. It can take 8 or 9 months in order to build up to therapeutic levels. But if you have something like liver cancer that's fatal in 6 months, you're kind of defeating the purpose. So I tend to go more towards ozone therapy. You can get higher levels in your system than with the peroxide therapy. Where the peroxide therapy really comes in handy, though, is if you have external cancers or cancers that can be accessed with a needle.
You poke it right into
directly into the tumor, and it will obliterate the tumor in a matter of seconds. Now, I'll explain ozone therapy.
Now, is this straight peroxide, or is it diluted, or?
If you can tolerate the pain, because it is going to burn like crazy, you can inject it 35% directly into the tumor. And if you're not experienced with injections, I don't recommend doing it yourself. Have somebody that knows what they're doing do the injection for you. You do not want to inject it into a blood vessel. So
what would happen if you did?
You can hemolyze the red blood cells. You can eat away the blood vessels. It can cause a lot of serious damage. Potentially, if the peroxide breaks down, forms enough air bubbles in there, you can actually end up getting an embolus. So you don't want to inject into a blood vessel.
But isn't it the tumor actually fed by blood vessels? So there's a very good chance that you could.
You're gonna, if you ever see it, I've actually seen this in person. But if you inject the peroxide into the tumor, it obliterates it on contact. It is the wildest thing to watch.
What happens?
It's like a gunshot just going through, and it blasts apart the cells on contact. The reason being is that your healthy cells and your cancer cells have different morphologies. The main thing is that your healthy cells have enzymes that can break down peroxide. You have your catalase, your peroxidases, your superoxide dismutase. These enzymes can break down peroxide to protect your healthy cells. Cancer cells lack those enzymes. So what happens is the peroxide enters into the cell, it swells up like a water balloon until it bursts. And the process of the enzymes around there that are actually breaking down the peroxide, they'll form singlet oxygens, which creates new lipid peroxides. Those lipid peroxides go into the cell again, the next one, and swell it, burst it, starts the whole process. So it's a chain reaction. give you an idea, I had a tumor roughly about that big, and they injected peroxide at the base of the tumor using an insulin syringe, and that's 1 cc. It's a tiny, tiny amount. And on that, they're in units. 1 unit on that 1 cc took out half the tumor in a matter of seconds.
Whoa.
So it's a chain reaction. You don't need a large amount.
It's like an atom bomb going on.
Exactly. But I said, it burned.
Can you somehow, like say it's inside your body, like can you inject a needle long enough to get into an internal?
That's a little bit trickier. There are cases where yes, you can't, like a breast tumor. You could probably deal with a breast tumor if you can find it. Make sure you get the needle into the tumor and again not into a blood vessel or anything like that.
You'd have to use a scope of some kind, or
if you can feel the tumor and guide the needle close enough, you can pull it off. Again, ozone is actually going to be a little bit safer.
Okay, so I have an ozone machine, and it's basically oxygen is O2, ozone is O3, so it's got an extra molecule, right?
O3 to O25. It's anything O4 to O25 is known as polyatomic oxygen molecule or long chain ozone, and as it breaks down, let's say you got O25 for example, it'll break down to O24, O23, O22, and as it breaks down, it's releasing those singlet oxygens. And these singlet oxygens are very, very powerful free radicals. And again, free radicals are not a bad thing. They are not a bad word. They're actually beneficial. We cannot survive without free radicals, like hydrogen peroxide is generated by the body to destroy cancer cells, among other things. Your natural killer cells, when they find the cancer cell, they'll actually attach to the cancer cell, inject peroxide into the cancer cell swells and bursts. So our bodies use the same process, but the hydrogen peroxide is considered a free radical. And so we need these free radicals for various purposes, like peroxide also forms your thyroid hormones and so on and so forth. And when you stop and really think about it, the free radicals are designed to destroy disease cells and pathogens because they have the antioxidant capabilities that your healthy cells have. So the free radicals have their purpose, but like I mentioned before, too much of a good thing.
Right, exactly. So ozone is like my machine. You have the oxygen machine or an oxygen tank or a scuba tank or whatever, which then that goes into the ozone machine. What it does is it takes the oxygen, zaps it with electricity, right, and that turns it into like that. That's why lightning up in the when you have
it takes storm. The O2 splits into O1s. The O1s form back into the O3 and sometimes long chain ozone, depending on what kind of machine you're using. Now there are ultraviolet units. I do not recommend ultraviolet for therapy unless you're going strictly external. What you're looking for preferably is a cold corona. And some people will also, they're using the term cold plasma too, but technically cold plasma is the same thing as cold corona. It's just instead of using solid electrodes, they're using gaseous electrodes. It's the real difference between it. So, but you want a cold corona type device. You do want to start with oxygen if you're going internal, because if you're using air, for example, like you mentioned scuba tank, if you're using air and you don't have a cold corona, say you got ultraviolet or a hot corona machine, it will form acids that can damage your tissues. You're going to form nitric acid, you're going to form sulfuric acids that are very irritating or damaging to the tissues. So the oxygen goes in, it's split, and it recombines back into O3, and that's what goes into the body. Now, how the ozone works for cancer, there's a multitude of different things it will do. For instance, we mentioned that most cancers are caused from viruses. Ozone destroys viruses. It destroys bacteria. It destroys fungi. So it'll destroy cancer pathogens to start with. It also forms peroxides. Peroxides activate your white blood cells, so it's actually boosting your immune system. It will stimulate the formation of interferons, interleukins, tumor necrosis factor, again, all immune factors for the body. It will destroy the cancer cells through direct formation of peroxides again. So as on your cell membrane, you have lipids on there, and what's going to happen, the ozone reacts to those lipids, forming what's called lipid peroxides. And again, those lipid peroxides go into the cell. The cancer cells can't break down those peroxides. They swell and they burst. When it touches your healthy cells, the healthy cells simply just break down the peroxides into water and oxygen. So the ozone is selective to the cancer cells. It does not destroy your healthy tissue at therapeutic doses.
And how do you get ozone into your body? Because you can't just breathe it in straight.
No, you don't really want to to breathe it. It can damage the lung tissue, especially if it's concentrated. But there's different ways of applying it depending on what you're treating again. There's everything from, there's hyperbaric ozone that there's some doctors in Germany doing. You can do subatmospheric applications. There's autohemotherapy, both minor and major. There's injections, which can be intravenous, interarterial, interarticular.
But how can a person at home who doesn't have a doctor to work with do it? Because what I do is I put the hose in some water and just let it bubble for 5 minutes, and I drink the water right away.
Yeah, that's one way to do it.
Because the stomach is actually permeable, right? It gets into your blood system pretty quick that way.
Actually faster than the lungs.
That's pretty. See, people don't understand this. They think like you're breathing it in, it gets in your bloodstream, but the stomach is amazing.
Yeah, somewhere back, I think it was around the early 80s or so, the Russians were experimenting with called oxygen cocktails, and they'd go out there and they would just, train and stuff. They build up all this, the hydrogen protons again, for cause the burning of the muscles. They build like hydrogen protons, and so they would take these oxygen cocktails, which are basically water supersaturated with oxygen and some vitamins and minerals in there. They would down the thing. They found that the oxygen would absorb through the stomach wall 40% faster than it did through the lungs. So remove all those hydrogen protons and then go back out and they can burn for a while and go back and drink an oxygen cocktail. So it was a way to up their training. So yeah, you can ozonate the water. You really want to put a diffuser on the end though, not the stone diffuser, but try to find the plastic aquarium diffusers. They're little white ones, or there's wood ones out there too, which form even finer bubbles. But they create more surface area, and so the finer the surface area, the better it will saturate your water. Make sure your water's cold too. Cold water will saturate ozone better than warm water will. Put the stone down as close to the bottom as you can, so again the ozone that bubbles up has more contact time with the water. Right. And then drink it right away, preferably on an empty stomach. And that is one way to do it. Again, depending on what kind of cancer, where it's located, there's still different ways even at home to administer it.
For example?
Most cancers, rectal insufflation is the best way to go, particularly for things like prostate cancer. But the colon wall is very, very high in little blood vessels that will absorb the ozone readily into the bloodstream, and it will absorb through the entire system.
So what you're telling people to do is to put the ozone in their butt.
Exactly.
How do you do that?
On the output side, you're going to have a tube or a catheter of some type. Usually I just use them like drip irrigation tubing because you got disposable catheters, or you get vinyl tubing or whatever. And you just come down to about 6 inches in length. You want to lube them with something along the lines of either olive oil or KY jelly. Never ever use Vaseline around oxygen regardless, whether it be ozone or oxygen. It's a bad combination, so never ever use Vaseline with the stuff. So you lube the end. It's just inserted just right past the sphincter muscle. You don't have to go very far up, just slightly in, and the pressure that's coming out of the machine is going to be very, very low. I try to run it about 1/10 of a liter per minute because I found at that rate that it will actually absorb through the colon wall at the same rate that it's being infused.
Because if you don't, you're going to blow up like a balloon.
Exactly.
Pressure. Whoa! Bloating like crazy.
Very uncomfortable to start with. You can rupture the colon and stuff. So yeah, you want very, very low pressure. Yeah. Now the first couple of treatments, you're going to bloat anyways. You got a lot of die-off and stuff initially, and you're going to bloat like crazy. You might be able to get by with 5-6 minutes max at 1/10 of a liter per minute. But you have to look into the rates and stuff. You want roughly about 30 gamma on the machine. But anyways, your first couple of treatments, you're going to bloat like crazy. Usually after about the third treatment, that bloating goes away, and you can do longer treatments. I usually go like 20 minutes. For a cancer patient, I recommend 20 minutes 3 times a day. Drink a lot of water. Initially, you will feel kind of flu-like. Again, that's because it's going to stimulate the formation of interferons and stuff like that, different immune factors. So you might feel a little flu-like for the first couple of days. Just lots of water, that will go away as well. But the nice thing is that the ozone cell will go into the bloodstream. It's like before we had hypodermic needles, everything was given rectally. Because that large number of little blood vessels on the colon wall, it absorbs right into the bloodstream. The colon is very, very absorbent. So as you inflate the colon with the ozone, it goes right into the bloodstream, it circulates through the body, and it will reach the tumor. Now, certain tumors like brain tumors, the best way I found is to go right through the ear. Basically, you're going to turn the head sideways because ozone weighs more than air does. So you want it to actually sink into the ear. So you take the tube and you just kind of hold it there for 20-30 minutes. Try to keep a fan to blow the ozone away from so you're not inhaling it. You want to blow it behind your head. Anyways, it'll absorb right into the tympanic membrane, goes right into the brain. It will blast apart the brain tumors. It's good for retinal tumors, stuff like that. So anything in the head area.
Your ear is not people think that the ear is a tube that goes right into your sinuses. It's actually closed. There's no opening in there. It just goes through your
the eardrum or tympanic membrane. There's a very thin membrane there, and the ozone will go right through it. Just like the ozone will absorb through your skin too. Yeah. It actually goes both ways. Like you're doing even rectal insufflation. If you wait 20 minutes, you smell your skin. You'll smell the ozone coming through the skin. So it goes both ways.
I love ozone. I'm just fascinated with it. We could write a book about it and spend 2 hours talking about it. It's people are going to ask where to get it. It's actually the government, the medical field doesn't want you to know about this stuff. So the people that sell the ozone machines, they have to call them water purification systems or something like that. This is how you make ozone. It's actually a two-part process. First, you have to make oxygen. So here we have a standard hospital oxygen machine, an oxygen concentrator. You can get them for around $500 to $2,000 depending how new or old they are. The oxygen comes out of the oxygen machine and goes into the ozone machine, which is this little device here. It's like a secret case from a James Bond movie. What this basically is, inside of here is a glass tube that has this high-powered electrical lightning bolt in there. And what it does is it electrocutes the oxygen and turns it into ozone, O2 into O3. So in one end goes the oxygen, out the other end comes the ozone out of this tube. This tube is made out of silicon because it doesn't oxidize as fast as plastic. Even so, look how yellow this is. The ozone is so powerful, it's actually corroding the silicon and turning it yellow. That's how powerful the ozone is. You can get ozone machines online at places like synergyozone.com. So you can study more of that online.
If you go into mountainmistbotanicals.com and then on the left-hand column, you'll see what says James's articles.
Yeah.
Click on that, and there's one, the chemistry of ozone and cancer, and there's also another one on cancer in general. But the one, the chemistry of ozone on cancer, will give you more details on exactly how the ozone works. And I put one of the studies up there that's on Medline, how ozone selectively inhibits human cancer cell growth or something like that.
Right.
And that's been out there for a while. And there's a bunch of other research out there too. It's just, it's a lot more obscure.
Ozone is the stuff that you smell in the air after a thunderstorm because the lightning actually zaps the air and creates ozone in the air.
Around high voltage. Yeah, like copying machines, you'll smell ozone around copying machines, the high voltage.
Yeah. So what's interesting is other than just killing diseases, ozone also helps neutralize heavy metals and toxic stuff in your body.
It can form oxides. They can be precipitated out of the body. For one, it'll destroy carcinogens like xenoestrogens, dioxin, DDT, PCBs, things that are stored in the fat tissue, which is really hard for the body to remove because there's not much of a blood supply to the fat tissues. Ozone goes right through those tissues, goes right in there, and it'll oxidize them.
All kinds of things that are fat-based toxic stuff.
Oh yeah, and these people are exposed to Agent Orange because that's dioxin. And so all these people come back from Vietnam, they're exposed to Agent Orange. Ozone therapy will destroy the dioxins that are stored in their tissues.
It's amazing stuff. I mean, this is what nature naturally creates if you were to live in nature and go run outside when there's a thunderstorm or something.
Yeah, and ozone gets a bad reputation because they try to equate it to smog and things like that. Yeah. But really, it's an indicator because the higher the level of smog, it's the ultraviolet light reacting with the smog that creates the ozone. So it's more of an indicator level of smog levels, not really a component of smog is the way I would look at it.
Yeah.
It's going to oxidize like CO, which is carbon monoxide, which is highly dangerous, into CO2, which isn't as dangerous, and the plants will take up. So it actually has its benefits in nature as well.
Great. Well, James, we can keep talking for hours, and I'm sure we will, because I want you to come back and keep talking more. So next time we'll talk about, oh God, we'll probably have 200 more.
Oh yeah, there's all sorts of things we can think about.
Well, thanks, James. I appreciate it, and I'm going to really keep you guys in touch with this guy. He's just this wealth of information, and really is going to help you a lot. Thanks again, and we'll see you next time.